let's go about this process of discovering what's called the first fundamental theorem of calculus. So let's start with number 7. First it says find the integral from 0 to 5 of f prime of x dx. So here's my f prime of x. I just have a graph. I want to find the integral from 0 to 5, so that means I need to find the area under this curve from 0 to 5. And that shouldn't be too hard to do because this is a nice rectangular shape. So to find the area of that is base times height. That's the area of a rectangle. My base is 5 wide and my height is 3. So I should have 5 times 3 is 15. Okay, B. Write an equation for f prime. So let's see. The equation for this is just a straight line at 3. So the equation should be y equals 3. Okay, find f of x if f of 1 equals 4. So finding f of x, that means this is f prime. So I guess I should label it. Let's label it as f prime of x. So if I want to find f of x, I need to take the integral of that equation. Well, we know that one. That's just going to be 3x plus c. And right there, there's our initial starting point so that we can calculate c. So 3 times 1 plus c equals 4. So I should get that c equals 1. So f of x is going to be 3x plus 1. Okay? Now, next step, it says I want to find f of 5 minus f of 0. So they're getting those numbers from the upper and lower limits. So I'm going to take my antiderivative, 3x plus 1, and I'm going to find f of 5 minus f of 0. F of the lower limit minus f of the upper limit. Sorry, other way around. So let's plug 5 in. 3 times 5 plus 1 is 16. Minus f of 0, 3 times 0 plus 1 is just 1, and 16 minus 1 is 15. Okay, now here's what I want you to do. I want you to go through this same process for number 8. Find the integral, write an equation for f prime. This should just be a y equals mx plus b equation for this line here. Find the indefinite integral using the rules we've learned so far, and then find c using this point. And then finally plug 1 in and negative 2 in and subtract them and see what you get. So I want you to pause, try all 4 of those steps on your own, and then we'll come back and see how you did. Okay, let's talk about what we got. So there's my signed area. I have this little triangle here and this big triangle there. So my little triangle, 1/2 base times height. So there's my base is 1 and my height is 2. So 1/2 times 1 times 2 is 1. Except remember that this is a negative triangle because it's below the x-axis, so it should be a -1. Then I have my big triangle, 1/2 times base times height with a base of 2 and a height of 4. Multiply all those together, I get 4. I add my 2 signed areas together and I get 3 for A. Now writing an equation, this is a rise 2 run 1, so slope of 2. And B is our y-intercept, which is also 2. So there's my f prime equation. Next, find the integral, which, oops, I should have a dx right there. So we know how to do that. There I did that and simplified it a little. Plug in my starting conditions and solve for c. So this is my equation for f of x. Now I'm going to plug in the upper and the lower limits. So plugged in my upper limit, plugged in my lower limit, and I subtract them and I get 3. Now you'll notice so far that A and D are the same answer. So we're going to try one more example of this to make sure this works and see if we can form a theorem from these three examples. So this one is worded a little differently, but it's the same thing. So in A, we're going to find the displacement from 1 to 4, which remember that's just x of 4 minus x of 1. Displacement is the starting value minus the ending value. So I'm going to plug those values in and subtract them. Next, find the velocity equation. So you're going to take the derivative of this, because this is position. So take the derivative to find the velocity, make a sketch of it, and then find the signed area by using triangles from 1 to 4. So once again, I would like you to pause the video, try this example out on your own, and then come back and see how you did. Okay, welcome back. When you plug x of 4 in, you should get 5. When you plug 1 in, you should get 1/2, and if I subtract them, I get 4.5. I found the derivative of this equation, and I got negative t plus 4. I graphed that linear line, and I want to find the definite integral from 1 to 4. So here's my shaded area, my signed area. It's a triangle, so 1/2 times base times height. Here's my base of 3. Here's my height of 3. So 1/2 times 3 is, once again, 4.5. So you'll notice in all of these, there is some sort of connection between the integral of the derivative and plugging in the upper and lower limit to the antiderivative. There's a connection here. So in the next video, we'll formally go over the first fundamental theorem of calculus and talk about that connection.